All right, so let's try and pick up where we left off, which was getting the pieces to fall down. And before I add new pieces, other than just the L piece, I want to think through and do a little brainstorming on how I'm going to handle input and spawning the pieces. So I want a piece to start, fall down. When it touches something, spawn a new piece, fall down. When it touches something, the piece can start falling and a new piece gets spawned, and kind of implement the basic, I don't know what to call it, the basic cycle of the game, of the underlying game. And so far what I have is, I'm going to do this live, I haven't prepared anything, but I have something I call the player controller. And the player controller, let's zoom in a bit. The player controller does what? It does a couple of things. But most importantly, it maps a GameKit player, which can be the local player, but I hope in the future it can be also a remote player. And let me just group these. And there's this other thing, which is basically the current shape, the current node. And it's an optional because at a given point in time, or when it's initiated, you might not have a shape. And so then this is a mapping between a player and its node, and it receives input, and it controls what happens with the shape. But we need something more that controls the actual game. So let's draw the game scene. So in a game scene, what you have is, come on, can you please? All right. So in a game scene, you have, let's say, 4 players, up to 4 players. Well, let's say 2, so we don't have to draw that much. Let's say there's 2 players. Each of them takes up half a screen. And in that screen, what do we have? We have some kind of game piece falling. Let's draw this like this. So we have a game piece falling here, and we have a game piece falling here. Maybe it's rotated, and okay. And we need something to say when to spawn and when not to spawn. And so there's going to be a spawn point here. It's going to be invisible. So actually, let's change the color. Let's say it's going to be orange here, but in the game it's going to be invisible. But it's just a thing that we need. So we need the spawn point. We need a piece to fall. We need some kind of base at the bottom. And currently I'm just recreating what I already have in the current version of the game. Background. All right. Cool. Okay, so far so good. Let's color this one in a different color because it is player number 2. So local player and player 2. All right. So the scene, what does the scene do? The scene is going to just orchestrate some stuff. It won't do any game logic. So the player controller is going to match this node and a player. And there's going to be an input source. let's say there's an input source here. Let's call it keyboard. And let's make another one. Let's say the second player is using a gamepad. Okay, so far so good. We have two input sources, and I don't have anything where anything in particular that I'm shooting for. I'm just kind of thinking I'm making it up as I go, so to speak. And I'm trying to like put all the involved pieces on the canvas, and then can see how they fit, how they should fit together before I start coding. So there's an input source, and I want that input source to go to a player controller, and there's going to be two player controllers. So I want two player controllers here. So one player controller is mapped to the local player, and there's player controller 2. Let's color code these. Let's say local player 2 is blue and local player 1 is red. I called this one local player and not player 1 because the main kind of host / player 1 / main entity in GameKit is called the local player. And then player 2, if this is a local match, player 2 is probably going to be a guest player. So here, let's say this is player 2. And here we say this is local player. Input source, the way we have set everything up right now, input source is also tied to a player. So when we receive an event, then we know which player is the source of it, right? So we have the local player here. And for the second input source, it's going to be the same, but with player 2. All right, so far so good. So we have two input sources. We have the scene. So this whole thing is the scene basically. And we have player controllers. And player controllers can rotate the shape when there is a shape, but that's not all they do. I'm not gonna like maintain. Should I maintain two of these? Okay, let's keep it. All right, so what happens when we start the game? We can spawn a piece, have it fall, and then the player controller could detect when the piece collides with another piece. There could be some kind of, because it has the node, it could listen to its some kind of delegate method that notifies when the physics body experiences a collision, and then it could spawn a new one. But it feels like missing, like putting multiple, like making the responsibilities of the player controller too complex. Like I want something to just deal with input and how to map that input to shape rotations. So the player controller is only going to control the currently active piece, but that is not, but that is not the main responsibility. No, not the main responsibility, but that's not all we need. So we need something to take care of this whole kind of game view, game context for player. So if the whole match is a single game, then every player has their own like slice inside of this game. The overall scene could manage the entire game, but each player needs something. What do we call it? Let's call it game. Well, let's call it a game slice. Why not? Let's go for it. Let's call it a game slice. It's a weird name, but context is very overused. And I like slice because it means it's like a little window in a bigger hall, because it's not all of it, and it's kind of like a window in the entire game. So let's say there's a game slice. What does the game slice have? The game slice is going to have a player controller, so this is one thing that the game slice is going to have. And so the game slice can take care of the responsibilities for starting the pieces, spawning the pieces, kind of keeping track of game mode of the game mode. So we need information about the game mode, right? Or like we need to know when to stop spawning the pieces. For example, local player 1 could have lost the game already and there's no more pieces, but player 2 is still going for it, or maybe local player 1 wins or something. So at some point the game slice should just say, I know, but we don't want the game slice to take care of game rules, because then we introduce the possibility that, you know, two different game slices could try and apply different rules to their views into the game. No, it should just mechanically do something. It should emit events, I think, saying player reached the top, player ran out of pieces. So the game slice should take care of spawning pieces. Actually, it needs some kind of game context. So we need to know how many pieces are we going to spawn. Like in some game modes, you might have 30 pieces and then you're done, or you might have an infinite amount of pieces, and first one to the top wins, or whatever. So the game context, or maybe like the game mode. It's not just the mode. So the game let's see what could be in a game context. So the game context, what does it have? So the game mode is one thing that the game context could have. Game mode. So what is the game mode? The game mode, let's say it's the puzzle mode where you have to fit enough pieces in a specific underneath a specific height, and so either you do all of that, so the game mode could be puzzle, 10 pieces, and the order of the pieces, and maybe the position of the configuration of the game board. So the game board could have different layouts. So the layout is just a thing on its own. Actually, so what the game context needs is the base layout. And the base layout can be, what could it be? Should it just be a shape? It could just be a shape. Then it could be, so what do we want the slice to do? We want the slice to know when to stop spawning pieces. And kind of we want to keep track of how the player is doing. So actually, we do need the game mode. I think we do need the game mode. We need to know what rules we want to apply. So that we can keep track of the player. It's like a game unto its own. Like a game slice is a microcosm of the entire game. Like it's a game unto its own. And then the entire game is just like multiple game slices together. So if it's just one player playing, the game slice is the full game. If it's two players, they're both playing their own game, but the game is just kind of like coordinating. I don't know if this makes sense what I'm saying, but in my mind it does a bit. So we need to know the game mode. Let's add an example. Puzzle. Let's say puzzle, for example. Yeah, let's just go with the puzzle mode for first version. So the puzzle mode. Actually, what we could do is we could have each. All right, so the game context should actually be the game mode. And the game mode is an enum with associated values. And it has stuff like puzzle mode. And what the puzzle mode has, let's elaborate here. The puzzle mode has all pieces and their order, so we know in what order to bring the pieces. We want to know the base shape, and then we want to know, so the base shape is just, you know, like a column maybe, or like two columns, or like a square or whatever. We want to know the difficulty, right? Because if there's some like we might want to do random buffs, or like random ability, give out random abilities based on how many turns have elapsed, or based on what you've done in the game. So we want some kind of information about some kind of ability factory. We could just say, you know, game mode, game difficulty easy, and then the game slice could use that to determine when to do what. But actually I feel like it would be neat to encode the entire rules in like an enum value, in an enum case with associated values. So we could have, so a single game mode enum case could encapsulate the entirety of the rules for a given match. Which we could put, we could make a method on the enum saying like X many shapes have passed, like do we get any abilities, or interesting. So in Tricky Towers, if you play the race mode, race to the top mode, then you get like a floating bar, and the first to reach it, the bar's coming down, and the first to reach it, it gets, well, not the first, but like whenever you reach it, the bar gives you an ability, and then it jumps back to the top. And I feel like that is like logic that is more encapsulated in the game slice, actually, not the game. Game mode. So the game mode should just be the rules. So let's say there's the difficulty. So there's the rules. The interpretation of the rules is in the slice. Pieces list. Base shape, difficulty, stuff like that. Okay. So the game slice has the player controller, it has the game mode, and There must be some kind of special something. So there should be different game slice implementations based on the rules, because, okay, so we have the game mode and we know the rules of the match, but how do we handle the case where Race to the Top has the floating bar, for example, but a different game mode might have abilities based on how many pieces you've played, and yet another game mode might apply different effects on your pieces based on the difficulty and based on the elapsed time, but not based on how many pieces you've made. So there's very different game modes. So the game slice might have to be paired to the game mode. So in that case, the game mode might not be an enum. It could just be a struct then. It could be a struct containing the piece list. Yeah. Let's say game config. That's not, yeah, it's the game config. I mean, I'm saying game when I mean a match. So the game config is the piece list, the base shape, difficulty, etc. Let's add, like, there might be more stuff, but we don't care what, but it's just basically a list of things. We want this to be a list of things. We don't want this to contain any logic at all. And the game slice will contain the logic. And so there's going to be a root game slice thing, just like an abstract thing. And then based on the game config, based on the game mode, which is just a simple enum like puzzle, whatever. And then based on this game mode and the game config, we create the actual implementation of the game slice. So the game slice is the game slice. Is it a controller? Game slice controller, puzzle game controller, puzzle controller. Let's call it a game controller. There's going to be multiple game controllers. Game slice controller. All right, let's say game slice controller, puzzle game slice controller. And actually, most of these things are game mode agnostic. So the player controller, we want that. The game config, we want that outside here. The player controller, we want that here. And then this is a subclass. All right. All right, does this make sense? I don't know. Let's see. And this is like an abstract. This is going to be like an abstract piece class. Abstract in the sense that it doesn't need to instantiate it directly. And so the puzzle game slice controller is the part that's going to implement some game logic. So it gets updates all the time, and it knows how many pieces have been processed. Okay, so actually, what does it know? Let's group these together. All right, so there's going to be some methods that the game/controller can do, and one of them is going to be start. So when we call start, what it will do is start spawning pieces, and then the child class can override this if it needs to do anything. But no, like actually spawning pieces is very like, it's the same for every game mode. So start spawning pieces. Let's say it's func start. Now zoom in a bit. All right. So the base class knows to start spawning pieces. It's gonna need to know the spawn point. So it's gonna have a spawn point. It's gonna own a spawn point. It's going to own a spawn point, and then when you call start, it's going to start spawning pieces and assigning those pieces to the player controller, and then removing that from the player controller when there's no piece to control. So assign remove pieces from player controller. So this is like a responsibility thing that this thing will have. I'm going to put this here because otherwise it looks like it's related to the start method. I hope it's clear. This is like a responsibility list, and this is like a function list on the left. All right, so we have a function called start, which is going to start spawning pieces, and then we will have okay, so let's walk through what's going to happen. The game calls start, we spawn pieces, we spawn a piece, it goes on the spawn point, falls down, the game/controller attaches to the piece some kind of delegate. Delegate of current piece. For collision callback. So when we get that collision callback, we detach the piece from the player controller and maybe spawn a new piece. Or we evaluate if the game is over. We're gonna have some abstract methods like, no, not abstract, but like virtual. I'm saying virtual with, and I mean that I know that you don't use the virtual keyword in Swift, but it's just to indicate that it's meant for the child, like game mode to override. So each game mode is going to be a child class of this game/controller, basically, which doesn't, when I say it out loud, it doesn't really make sense, I think, but I think it makes sense structurally as a model, but the naming is not great. But you know, naming is hard, so let's not rename things just yet. So there's a virtual function that's gonna be piece update pieces placed. Piece done, and there's going to be a new piece, so we know what the new piece is going to be. We could do that. You could say new piece, and then in the child class we could keep track of like how many pieces have cycled through if we want that. All right, let's say piece done, and we pass in the new piece. Well, we don't even need to pass in the new piece. It doesn't really matter what the new piece is like for the game mode, I think. What does the game mode need to do? The game mode needs to know how many pieces have elapsed. It needs to know how much time has elapsed. So it needs some kind of update method that we can override. Like a update frame. And so in that update frame, we can take a look at how much time has elapsed. We can move like some stuff independently from the player, like that bar that comes down, and when you reach it, then you get an ability. When we need to process some input also here, because the player controller, okay, so the player controller can process rotating shapes, but what happens if we want the player controller, if we want the player to play an ability? So that's input that goes to the player controller. But then the player controller needs to propagate this out. The player controller needs to tell the game slice controller, oh, I played an ability, and you might actually even play an ability that applies to different players. So we don't want to propagate things out. We want to catch that at the root. So if there's going to be an input event saying, hey, play an ability, we want to play that as soon as possible. But who keeps track of the available abilities? So, good question. I think the game slice keeps track of that. So we will keep the track of available abilities in the game slice controller. And then the player controller might want to say, hey, play this ability. Maybe this terminates here actually. So the input is going to flow like from the scene to the game slice controller to the player controller, but we could just grab it here and say play ability. So this is not going to be a virtual. This is not going to be a virtual method because we are going to handle it ourselves in the base class. So there's going to be a play ability method. This is going to do something with the ability. Do we need to let each game mode customize how abilities get played out? We do not. Do the game modes control what kinds of abilities might appear? Yes, that is true. So there might be some kind of virtual generate ability method. So the base game slice controller keeps track of when we need an ability, when an ability needs to show up, but the types of abilities should be generated by the, I don't know, it's actually the opposite. So the child class of the game slice controller is going to be the one to decide when to generate ability and what kind of ability to generate. So actually there's going to be a add ability method, and this one is going to be called by the child class. All right, so the child class, let's make this a bit bigger, and let's put down some responsibilities for the child class. Call add ability when appropriate. Ability, and when we play the ability, we want to specify like the ability slot. So there should be multiple ability slots. There's like an ability that applies to yourself, or that an ability that applies to your opponent. And I am just like lifting these game design ideas from a different game. Because yeah, like that's the whole point. Like I am not doing an amazing game design exercise here. It's more a technical exercise. So I'm borrowing these game design ideas. But so we want to add the ability and ability slot. We want to add an ability to a slot, and then we want to play an ability slot on input, process input, or pass to player controller. So this is one thing. If we have the input for rotating a piece, we should give that to the player controller, and the player controller can rotate it. But if there's input about playing abilities, then we want to do it here. So this is kind of inconsistent. At this point, the player controller is doing a subset of what the game slice controller is doing, and it makes no sense to me. Feels weird. It feels wrong. It feels incomplete. So we could say that the player controller is actually the one to play the ability. The player controller could keep track of its like parent controller, and when it receives red input, then just play that button, play that ability. It's a bit more convoluted because we would pass the input through the game slice controller to the player controller and then back, I think. All right, let's remove this. Let's say so what does the player controller do? Rotate, shape, request abilities. So the main thing is not the main thing, but honestly, the only thing the player controller does is process input. And I like this because it sounds simple. It doesn't sound convoluted. It sounds very simple. It processes input, and it rotates the shape, and it plays abilities, and that's it. And so we need to know what is our game slice controller. So that's how we interact back up. It's I don't love that there's like this too bi-directional dependency though. that also feels wrong. Like this dependency should not be bidirectional, I think. All right. So what do we have now? We have the game slice controller. Very bad name. The more I think about it, oh my god, I'm bad at naming. Player controller processes input, rotates shapes, plays abilities. Maybe we can avoid having a bi-directional dependency between the game controller and the player controller. Maybe we can make the game slice controller a non-optional thing here. But the game slice controller needs to know about the player controller because it gives and takes puzzle pieces away. It's a bit of a mess. How can we get rid of this? So actually, the game slice controller needs to be the delegate of the current piece. So we could move the current piece to be part of the game slice controller. And if that is the case, then we don't need a reference to the player controller. Boom. We just handle the current node. We set the current node and then we remove it when we don't need it anymore. And the player controller is like a layer, one level higher. And it controls the piece on the game slice controller if it exists or not. So actually it's some kind of like an onion architecture. Let's see. Ideally, I don't want bidirectional dependencies. It's going to be a mess otherwise. And so let's say this is the output. This is the outer perimeter. So what is the outer perimeter? The outer perimeter is the scene. If we go deeper, we go down, and then we want something that coordinates all the player controllers. So if we get remote input, or like any input that sends the input to the player, to the right player controllers, that could be the scene. The scene could just be the coordinator between multiple player controllers. So there are many player controllers. This scene simply coordinates them. Okay, so what? But if the game starts, the scene can say. The scene can say, "Hey, please start." But we need to call start on the game slice controller, and the game slice controller is nested inside the player controller. And then we need to call start on all of them. But if it's a remote player, actually, then the game slice will need to send that information. Ooh, handling the network. How am I going to handle the network as well? All right, well, let's take it step at a time. Locally, if I play locally, the game starts. I don't need anything. I can just have, player controller directly, but not below the scene. Player controllers. So we have multiple player controllers. Each player controller contains. What does each player controller contain? It contains a game controller. Let's call it a game controller at this point. No, let's stick to it. Let's say game slice controller because let's fix the naming afterwards. It's a game slice controller. So the scene owns multiple player controllers, one per player. And the scene handles input. Input routing to player controllers. Okay, so far so good. So the scene can do that. So how does a game slice controller communicate? How do we send? Yeah, the networking part is really tough on my old thinking head. But okay, at least this part is clear. Like input routing happens by the scene. The scene gets the gamepad or keyboard or mouse input. It sends it to the player controller. The player controller, well, actually the scene also pauses, unpauses. Is this something that happens at the root? It should, because input can get from any player controllers. No, I'm not sure. It's the scene's responsibility. So it should be the player controller's responsibility. Rotate, piece, pause, unpause, play, request, play, ability through game slice. Rotate piece directly, and pause, unpause the game. The game slice. So the game slice should also have pause, unpause built in here. And so when you pause something, it's paused for a bit, nothing proceeds. The current node is stopped. The game slice can do that. The game slice can like pause and unpause. And okay, one more thing that the game slice might need to do is if we pause and we have a tower being in the process of falling, it needs to stop it from falling. So actually, we don't need to keep track just of current nodes, but all past, like all nodes as well. It's like we need to keep track of the nodes that haven't been played, so we can pause and unpause. And then there's stop. So when we call stop, we might want to apply a visual effect on all the nodes, and then accept no more, like nothing. Ignore input, remove input, stop spawning nodes, Like it's like a pause, but you cannot go back. It's like it's terminated. We need to know all the played nodes, current node. We need to also know the remaining nodes, probably, because we might want to say oh, there's 5 nodes remaining, so you get like whatever something, you get extra points. And we want to know about the played nodes. So played nodes, remaining nodes, which is the current node. And one thing is, we need something above the game slice controller actually, because a game slice controller might terminate, but then what keeps track of the winner, for example? The game slice only knows about itself, right? Like the game slice is this is a game slice, but who then track, like if player 2 finishes first, how does this slice know to stop or whatever? Like there needs to be something greater than the game slice, and it needs to be something greater than the player controller, because a player should not be in charge of keeping scores for other players as well. So there needs to be some kind of game controller. Why am I calling everything a controller? Like game. All right, let's say it's a game controller. I don't know at this point. Like the naming is, it has run away from me. I don't know what to do about the naming, but I do know that I like the idea that there is something above the player that can do some orchestration of some stuff, some coordination. And then there's the scene. So the scene should be just like a raw dummy thing. I don't want to put too much in the scene because it's also related. It's like a plumbing layer. It's bound to the SpriteKit methods and input and like all the raw like plumbing stuff. I don't want to put any game logic in there. The game controller, what does that do? Game controller responsibilities. So keep track of scores, start, stop, overall game. This can handle, like, probably this layer is responsible for communications, but I'm not sure how. Communicate over the network. I don't know how this is gonna happen. I don't know how this is gonna happen, but I feel like it's not gonna be the player controller. The player controllers are gonna act on their respective game slices, but the overall game controller needs to be the one communicating. So suppose we have a remote player. The remote player finishes, no, not finishes, but the remote player like loses. Like their game slice says, that's it, you are like dead. Actually, this needs to be some kind of state, right? Like active or inactive. So game state. Let's say game state. What a great name for a great concept. So game state is going to be game state. It's an enum, and the enum is basically starting. So this is like everything's being initialized, running, and then finished. It's a game slice state actually, because the overall game is something else. So the game slice state can be starting, running, it can be finished. And then with being finished, we need some kind of context to determine points, maybe like number of remaining pieces. Tiebreakers. Well, okay, we can add that later. Like, let's not go that deep into this. It's like currently it's just a state: starting, running, finished. So slice controller, keep track of slice state. So to go back to the network question, if a game slice goes to the state finished, the game controller somehow needs to do this. So game controller needs to know about this. Monitor states of every slice. If every slice goes to finished, the game is over. And so how do we update the slice remotely? If a slice dies, it needs to detect this change and communicate remotely. So, communicate over the network. I'm going to keep the question marks because I don't know exactly how I'll do this, but changes in game slice states. And also the game controller is going to communicate what? Input. Like if I press right, does the game controller send this over the wire? So the game controller knows which player I am, and the game controller can broadcast my input to everybody, and it can say like, this player did this. So it can be some kind of central bottleneck for input, and then propagate the normalized input to player controllers. So how does the input work? Let's see. Raw input. So this is like a keyboard press. So then what we have is a normalized input event. For example, down, or let's say confirm. Then we have, we should have something that sends it across the network. So if I press something, I should, how do I, it's gonna be tough. Like I will need to synchronize across the network because everybody's gonna be playing their own thing, and what if it goes out of sync? I'll need to read about this. I have no idea how network synchronization is going to work in this game. But I do know that I will need to send input events across the wire, and then if it's a local input event, I can send it directly to the player controller. And if it's not the local player, no, like if it's a local player, I can directly send it to the player controller. If it's a remote player, Okay, so if it's a local player and I am playing with a remote player, I need to send them my input. So this normalized input event should be sent remotely. So I need to know which players are remote and which players are not remote, and then I can pass on input to local players directly, and for remote players I need to send it through a network layer. So does that mean player controller needs to keep track of his remote? Okay, so each player controller needs to keep track of if it's remote, and if it is remote, then we only process remote events. Okay, so if it's a remote player, we can pass the input events to this player and not send it anywhere. If it's not a remote player, then we always need to, okay, so the scene sends local input to the game controller, only local input, because that's the only type of input we can have. The game controller send local input to player controller, send local input to broadcast over the network, and send remote input to player controller, to the right player controller. So we need to know if the input event is local or remote, and then based on that we can know if we need to dispatch it or not. So where does this happen? So the scene is going to output normalized input events. Local is true. So actually maybe the scene, the scene shouldn't do anything. Like, the scene's already doing a lot. So the game controller is also doing a lot, but it's fine. That's normal. Maybe we can break it up later. So stop. Synchronize starts off on game slice controllers. Monitor states of every slice. Stop game when all slices finished. And then we want to send local input to player controller. Send local input and broadcast local input, and then we need to have some kind of normalized input event plus player information that we receive. This can be local or this can be remote, actually. Okay, so we can have local or remote input, and we combine that with a player that the normalized input event should also already be, so the normalized input event is going to be paired with a source, and then we map the source to a player for local stuff, and we receive it remotely. But basically this is what we send out. So okay, let's say game controller player controllers okay. I hope this makes sense. This makes sense currently. So basically, the game controller receives input events and it receives remote data. Maybe there should be some kind of network layer. There probably should be some kind of network layer. So the game controller does not need to worry itself with what's it called, with handling this communication. All right, so, but the game controller will need to update its state, and like states need to be sent out. Okay, okay, I think I got it. Network layer, let's call this the network layer, because everything is a controller otherwise. So, the network layer, what does this bad boy do? Network layer unifies local remote input events and passes to game controller, and it can do perform global state sync. So the individual player slices should probably play locally, acting on the same events, but because okay, I'm not completely sure how this should work in a game, but I assume that they're going to go out of sync, right? Like if I press a button and then I send that over the wire to a remote player, and then he applies that event, there's going to be a delay, and that delay is going to add up over time, and to have like more or less a similar experience, occasionally we need to resync the total state. This is like, I don't know how that's going to work. I'm going to read about it, but just intuitively, I think this is what needs to happen, and the network layer could take care of that. And so that means the game controller it monitors states, and then it says when finished, it's finished. It sends all input to the player controller, to player controllers. It does not broadcast anything over the network, because that's the network layer. Detect and state. So this makes no sense because like the global state sync is fine. It just resets everything to a common baseline. But individual changes of state, we should have those anyway because all the input is shared. So if we press pause, that is going to be sent remotely, and then pause is going to be applied remotely. So we don't need to detect anything manually. And so game controller looks a lot better now. Like there's a lot less responsibility. It just synchronizes start stop. Doesn't even need to do this. Like this I'm not sure what this is gonna do. But the game controller. Okay, the game slice controller actually has the starting state. And so what starts the state? The network layer? No. The game controller? Should the game controller own the network layer? Maybe. And then the game controller can say, please start the game, and the network layer can distribute that event to every other game controller, and then the game controller no. Okay, it could be the opposite actually. The game controller could own the network layer. If the game controller says start, it sends that to the network layer. The network layer can propagate it down to the player controllers, and it can also send it sideways to all the peers. The peers receive it below the game controller layer directly in the network layer and then send it down. But then the game controller does not know what we're started or not, but I guess it doesn't really need to do that. It can monitor the states of every slice anyway. Do we need an explicit start in general? I'm not sure we do, but let's look at this. So the scene gets input. It sends input to the game controller. The game controller sends input through the network layer. And the network layer can say, oh, this actually won't go there, and can send it remotely. So the network layer can be like, nope, sending this out, or sending this down. So game controller says start, network layer says start, and sends it remotely. And if it receives something from the remote game, then it applies that as well. Okay. Let's change the colors. This is like a black. Okay. So whatever it receives from the game controller, it propagates down and sends it, and it basically acts on the input from. Okay, so actually the colors need to be a bit different. So green and green. And red, red, and red. So everything the game controller gives the network layer, it sends down and it sends it. And then when it receives something, it sends it down as well. So there's two paths from the network layer to the player controllers. And if it's a local game, then the network layer doesn't really do much. It just sends everything directly through. So far so good. Then the game controller can occasionally, in every loop, the game controller is going to monitor the state of the slice, and when the game is over, it's gonna stop working. But when it stops working, then the network layer doesn't need to do anything as well. But what happens if the network layer receives a button press event after the game has decided to stop? Well, probably nothing, because even if it gets sent to the player controllers, if every slice is in finished mode, it should be discarded. So it's tricky. Synchronizing the game is going to be tricky over the network, because I don't know how that should be done. I guess there's a lot of trial and error in the future. Apart from that, I think I need a break. It's starting to take shape, like how everything should be laid out, but there's still a lot of things that are unclear. And some of these things will only become clear when we start actually implementing them. And I'm sure a lot of this is actually going to change, but I want to go through the exercise of thinking this through, just to kind of know about the various like edge cases and possible flows that might need to happen. And then it's going to be easier when I actually work and need to deviate from the plan, but I will have more like context in my mind to make better choices. But probably most of this is not gonna end up implemented as I've just described. But yeah, but it's better to like, I'm feeling better at least about it. It feels less abstract and much more actionable now in my mind. And I need to think a bit about how I'm going to synchronize the state, and if really game controllers should be, like what the dependency chain should be. But I like that I've kind of come up with a rough idea where the dependencies flow in one way, because if they flow in multiple directions, that ends up a really huge mess. And I think all of these concepts like make sense, because there's the scene, there's the game controller that owns like most of it. There's the network layer, which kind of tries to abstract away input issues. Then there's the player controller that processes input, and then there's the game slice controller, which in actuality is like a game mode implementation. And all of this kind of maps to the planned game screen. So good stuff. I'm gonna take a break now, and next time I might continue fleshing out the plan, or I might actually finish fleshing out the plan offline, and next time just get to implementing this structure. And that the main goal that I wanted to do is just to have the pieces fall. So the game mode is not going to be anything fancy. I just want something to fall to pieces, but I don't want to start coding that in a way that's going to be useless and that I will have to throw out later, right? I want to put in the basic skeleton of the overall, like the finished game. So I guess that's it for this time.